In this video, we're going to factor differences of squares. So let's talk first about what are square roots in squares. So if I take 3 times 3, I get 9. Okay, 9 is the square of 3, and 3 is the square root of 9. So remember those terms. 9 is the square root is 3. Okay, if we use one of these things that's called a radical, that means the square root of whatever I put into this. So the square root of 9 could be written as this, and the square root of 9 is 3. Notice also I could take 9 and I could write it as 3 squared. 3 times 3. 3 squared means 3 times 3. That's 9. So the square root of 3 times 3 is 3. Okay, square root of 16 is 4. 16 is the square, 4 is the square root. I could also write the square root of 4 squared equals 4. And I could go on and on, but what I want you to see is if you take a number and you square it, this means x times x, so that's some number. If I square root x times x, I'm going to just get x, because squaring and square rooting are opposites. If I take a number and I square it and I immediately square root it, I'm going to be right back to the number I started with. Okay, difference. What does difference mean? A difference just means a subtraction. In math, a difference is simply a subtraction. And so a difference of squares means you've got two square numbers like 9 and 16, and you're subtracting one from the other. Okay, now let's talk about a little scenario here. So what if I have a binomial? A binomial is simply a math expression that has two terms. Terms are things separated by plus and minus. Well, here I have an x and a 3, and they're separated by a minus. That is a binomial, two terms. And I'm going to multiply it by another binomial that is the same, except the middle sign is different. That's the only thing different. And let's FOIL this. Now, I'm not going to go over how to FOIL here. There's tons of videos on foiling. If you don't know how to FOIL, it might be a good idea to stop and look at a video on foiling. And foiling is just distribution. It just means you're multiplying this times this. If I FOIL this, okay, I'm going to take the two first terms, x times x. Then I would take the two outer terms, so I'm going to have positive 3 times positive x. Then I'm going to take the two inner terms, that's negative 3 times x, that's going to be negative 3x. And then the two last terms, that's negative 3 times positive 3, that is going to be negative 9. And then we always look for like terms. Well, here I have two x terms. I have a 3x and a minus 3x. What is 3x minus 3x? Well, that's 0. So these just disappear. And I just get a difference of squares. X squared is a square because it has a square root, which is x. 9 is a square that came from multiplying 3 times 3. And so it's a square, what we call a perfect square. And we have a subtraction of squares. So what we're doing here, we don't do a sum of squares. We can't factor a sum of squares. This only works with a difference of squares. Okay, now let's take this thing and think, what if you were given this and told to factor it? That would mean go from this to this. So let me write that down here. And this is what we are actually doing in this video. You're given a difference of squares. You spot it. You see, oh, x squared is a perfect square and 9 is a perfect square. This isn't like, 8.5 or 7. This is 9. This is a perfect square number. How do we factor a perfect square? A difference of perfect squares? Well, here's what you do. Based on what we saw here, okay, we went from this to this. Well, now factoring means we go from this back to this. Let's see if we can spot a pattern here. Well, I know I'm going to make two parentheses. That's what we have here. And I know this first number here, x squared, I know I'm just going to put the square root of x squared, which is x, in the beginning of each parenthesis. Then I'm going to take this number and think, what is its square root? And I'm going to put it in the end of each parenthesis. And then I'm going to make one of the parentheses plus and one minus. It doesn't matter which one, because multiplication doesn't have an order. 2 times 3 is the same as 3 times 2. So if you put negative, positive, it doesn't matter. And we are done. We have factored this difference of squares. Let's do another one. Okay, now I'm going to do this a little faster because we know the pattern now. I have a difference of squares, and so when I spot that, I know I'm simply going to do two parentheses. I'm going to put the square root of x squared in the beginning of each one. I'm going to put the square root of 49 in the end of each one. Make 1 plus, 1 minus, we're done. We have taken a difference of squares and we've turned it into an equivalent form where we have something times something, a parenthesis times a parenthesis. That's a big deal in math. Let's do another one. Okay, this one's a little slightly more complicated because there's more going on here than just an x squared, but 25 is a perfect square, isn't it? So square root of 25 is 5. I can do the exact same thing here. So the square root of 25x squared is going to be 5x. So I put one of those in each of there. You can try it if you don't believe me. 5 times x times 5 times x is 25x squared. Now I take the square root of 9, and that's 3, and I put 1 in the end of each parenthesis, make 1 plus, 1 minus, we're done. Let's do another one. Okay, so the square root of 9 is 3. Square root of x squared is x. Square root of 64 is 8. 1 plus, 1 minus, we're done. Let's do one more. Okay, what is the square root of x to the 4? Well, okay, so x to the 4 equals x to the 2 times x to the 2. This is x times x times x times x. That's the same thing as this. This is x times x times x times x. So the square root of x to the 4 is simply x squared. And the square root of 81 is 9. Make 1 plus, 1 minus. But notice here, inside of our factorization, we have another difference of squares. I can't do anything with this because it's a sum of squares. We can't do anything with that. But this is like a difference of squares wrapped in a difference of squares. So we can take this second parenthesis and we can do the same operation again. So this first one I'm just going to recopy, but then for this second one here, okay, what's the square root of x squared? Well, that's x. What's the square root of 9? 3. Make 1 plus, 1 minus. And so we went from this expression to its equivalent, this entire thing here. This is all equal to this. So basically we took this and we kind of unwrapped it, and it turned into all of this. Now, we're basically done, but I want to show one last thing, because what if you don't remember the shortcut of a difference of squares? Let's go back to, say, x squared minus 9, and you're told factor this, and you think, okay, that looks familiar. I know there's something I'm supposed to be able to do, but I can't remember. Okay, well, if you've watched my videos on just standard quadratic factoring, you can do that as well. You don't have to have the shortcut technique. You can do the regular technique. But the problem is here, we don't have a middle term. We're used to quadratics having an x squared term and an x term and a constant. Well, this has an x squared term and a constant, but it doesn't have just an x term. Well, we can fix that. Let's rewrite this as x squared plus 0x minus 9. Okay, there's lots of little cool things in math that we can do to make something more user-friendly. And so I haven't changed anything, because 0x, there's nothing there. It's just a dummy term, but it still works for what we want. So what would you do based on what we've learned in my other videos as far as standard quadratic factoring? What would you do if you had this quadratic? Well, you would make two parentheses, and you would say, okay, I'm looking for two numbers that multiply to 1 times 9, and they subtract to 0. Okay, if you haven't seen that video, you probably don't know what I'm talking about, so I would suggest going and watching it. But if you are already familiar with that, then you would just factor this the normal way. You don't have to use the difference of squares quick shortcut. You can turn this into the look of a normal quadratic and then just do the other method. So what two numbers would multiply to 9 and subtract to 0? Well, if they subtract to 0, they're really the same number. We're really looking for the square root of 9. Well, that 3 times 3 is 9. Okay, and then we put an x in the front of each parenthesis. Remember, we bring that sign straight down, and to get this sign, we look at both of these and think of multiplication rules. A positive times a negative is a negative, and we already determined these are the two numbers we're looking for. So we write 1 in one parenthesis and 1 in the other. Normally, I tell people write the bigger number first, but here it doesn't matter because they're both the same. And we're actually done. Remember, the shortcut technique is where you make your two parentheses and you say, okay, I'm going to put square root of x squared in the front of each one, square root of 9 in the end of each one, make 1 plus, 1 minus. Okay, so either way, you're going to get the same result. So my point is, I want you to learn how to do the shortcut factoring a difference of squares. But if you can't remember that, say you're taking a test or whatever, and you're sitting there thinking, man, what was that shortcut? Okay, well, if you can't remember it, just rewrite this into a standard looking, 3-term quadratic, and then just do the factoring that you know how to do. It'll take a little longer, but it's better than not being able to do it. But if you remember the shortcut, that's very convenient. You can go ahead and do this one.